So mentioned earlier, GitD, I don't know how much more time, but basically GitD is all about orchestrating and configuring containers to communicate well together, setting them up so that they start on time. One of the questions that was asked earlier is how do I guarantee that if my JBoss application requires a MySQL database, how do I guarantee that the MySQL database is started before the JBoss application comes out? Systemd is incredibly good at that. I cringe sometimes when I hear Docker building this technology, because a lot of this technology has been built over the years inside of Systemd, and they're starting to just look at this technology now. But if you use Systemd has all these really cool features for setting up your reliance between services on the system. So again, I look at services communicating instead of looking at its containers communicating. By the way, there's nothing to say that this MySQL has to be running inside of a container. So you could run a container that talks to the MySQL host. So you don't have to. The other thing that happens is people get all kind of on containers and they want to instantaneously jump 100% into containers, and they get into containers and they realize that certain applications still run the old-fashioned way, the way they run everywhere in the world right now. So I think you got to think about, you could slowly roll into container environments. You could, just start out with, say, running all your Apache, say a whole bunch of Apache instances inside of containers, and then have MariaDB or MySQL or PostgreSQL running database the same way you always run it. So as we build up, OpenShift's building up on top of GitD, on top of containers, and all of a sudden you're going to see this explosion of the number of Docker containers that can run inside OpenShift, getting up to hundreds of thousands of container instances. Another thing that was asked earlier is how does containers scale versus VMs? Well, very well. So if you really look at what a container is just a series of processes. There are processes running in a special state. So there's not, when I run an Apache container, I have Apache, basically have the 5, say, processes that Apache fires off. That's the only thing running inside of a container. If I run Apache inside of a VM, I have the kernel, I have the systemd, I have the journal, I have Getty and cron and all these. So if you look at it, just think about what's running in a VM. There's probably 100 processes running in there, and before you even get to the point of running HTTPD, right? So in a container, it's just you're running that application. So they're much thinner, they're much smaller. You can start containers in a second. I mean, basically, you start a container every just once. So in OpenShift, we're looking at scalability. We want to maintain the scalability that we have now, because Red Hat pays for all the VMs that are actually running OpenShift gears, and we would like to run hundreds to thousands of gears on a single box at a single time. So we want to maintain that type of scalability. So one of the goals, again, getting back to Atomic, is we really want to maintain, again, looking at the power of the operating system, we want to maintain at a minimalized rel version some of the great things about Linux, things like being able to choose which kind of file system you want. So which is the file system that is best for your workload, whether it's ext3 or XFS or GlusterFS or NFS. So all the file system support that's built into the Linux operating system and RHEL operating systems, you get automatic. I mentioned earlier automatic updates online, so you can update while your system's running, so you don't have to take down your services while you run it. With OS Tree and RHEL Atomic, we're actually sharing etc between the instances. So if you had again, the 7.0 and 7.1, they'd be sharing the same etc in var partitions, so that, and then we're working to make that possible. So, anyways, that's RHEL Atomic, and this gives you a little view of what the system. So, when I'm updating the system, I have the kernel running, user etc and var is updated, so now I'm going to update the system. So I go to a system with basically its own /user. This one has its own /user etc that's going to flip between the two. Colin grimacing as I'm trying to explain it back. So if you want to find out more information about what Red Hat and Project Atomic is all about, you can go to the website, projectatomic.io. There's also links to GitD. If you want to find out more information about what I'm doing, I'm Dan on Twitter, and my blog is danwalsh.labjournal.com. If you just look for Dan Walsh with Docker, you'll find out some other information. So let's go. Any questions? Yes. No, GitD is more of a command line tool for orchestration. So it basically, you can go in and say, I want to, with GitD, you can do things like I want to create 3 MariaDB instances or MongoDB instances, and then I'm going to create a PostgreSQL and wire all 3 of them together. And it takes care of the real advanced Docker stuff is all about these linking. So how do you link multiple containers together? How do containers discover IP addresses? So GitD is a tooling to do that. It was mentioned earlier at the DockerCon. One of the interesting things is, Red Hat comes out with GitD. Twitter has Mesos. Docker's coming out with LabSwarm, and then we had Google announcing Kubernetes. Well, it seems like everybody's sort of converging on top of Kubernetes or building around Kubernetes. So it was Google's Uber management of container technology. So we're looking at how to plug GitD into the bottom to get Kubernetes. We're also looking at potentially using Mesos, which comes from Twitter, to put it on the top and get all this stuff to work together to get really large-scale container distributions working. But yeah, at the low level, if you're just stringing together a few, GitD would be something to look at. As you scale up to, say, OpenShift type level, we have hundreds of thousands of these. You're going to be looking at taking things like Mesos and Kubernetes and getting to large scale. Anybody else? Yes.
So with the OpenShift and Docker integration, I guess, will you be able to deploy a Docker container to OpenShift, or is OpenShift just going to use the Docker containers underneath to deploy applications?
Yeah, well, in an OpenShift environment, the OpenShift has the idea of a gear, which is really sort of your processes running on it, and then they have the idea of a cartridge. Cartridge is sort of the software you're going to run. So if you think about it in one way, a Docker image would be the cartridge, and then the processes running on top of the container process. A Docker container is equivalent to GitD. I mean, it is equivalent to a gear in an OpenShift terminology. So in the beginning, I think we're going to be building up lots of images that you'll be able to run. The end goal is to then allow you to customize our images in a way that you want to run them, so you can build an application on top of an image, and then you'll be able to suck that image out. I mean, what I would like to see eventually, one of the beauties of OpenShift is we get all these people building applications. The problem is you need OpenShift to run your applications, or you have to pull them down and set up your own infrastructure. So what would be really nice is to allow you to build your own application and say commit it to a container, and then give me my container, give me my image back to my system. So you could go through a PaaS type environment, build a fancy application up, and say, give me my application. Now you can take that application and put it onto your RHEL box and run the application without the PaaS. So you wouldn't need to do anything. If we can get to the point that containers can contain, okay, which means, again, I don't mind you running in a container, I just don't want you to be root in a container. So if we can get to the point where containers can contain, then we would envision allowing you to upload your own image. Okay.
Well, one thing I would add.
That's a pretty, in my mind, that's a pretty steep step. I think if you want to pay us, then we could talk. But if you want it free, and I don't think you want us to give it out free. You want us to give it free to you, but you don't want to give it free to him. At least not in the same box, right?
Yeah.
One thing I would just add to that, though, is my understanding is there's some discussion about OpenShift running non-root Docker containers. So right now, Docker containers, you can start them as something other than root. And that, it kind of brings us full circle back to the origins of Unix, right? You have a time-sharing, unprivileged system, right? Yeah, and that's a lot safer than running Docker containers.
There are, by the way, PaaS servers right now that are allowing people to upload images and run them, and I think they're friggin' insane. Yes.
I guess I'm just kind of more of an opinion question. I mean, it seems like some of this container technology has been around. I mean, Virtuoso, OpenVZ, even Solaris Zones kind of did this stuff. What it seems like now
I'm sure the IBM guys are going to say they were doing this in 1967. You know?
Well, yeah, I mean, virtualization's not really new either. I'm just
pretty much sure. Yeah, it's not.
It just seems like it's kind of an interesting uptick now, lately, but
Well, I
some
think-
of it's been there.
I mean, I've been actually I've been working with container technology. So I would say argue containers really do three things. They involve three key components. One of them is as I said, C groups, which is process isolation of resource controls. Second is process isolation, SE-Linux. I've been doing that forever. And the third one is this thing called namespacing. Right? So I don't want to get too technical, but namespacing is basically fooling processes into looking at the operating system in a different way. So I can run in a process namespace and I only see the processes in my group. Or I can run in with a different network namespace, I only see my network. Well, one that we've been dealing with since RHEL 5, you run a RHEL 5 system is a PAN namespace, which we wrote in 2006. So it's been in Linux actually for almost 10 years now. So a lot of this technology has been there. What Docker there's two key things about Docker. One is their API, or their command line is friggin' simple. Okay, it's so simple. And the other thing that they really did that was critical to this was this bundling the image with it. Okay, so that you can basically take your application, wrap all the things that are critical to the application into the bundle, and then distribute it anywhere. Okay, so it's almost, in a lot of ways, Red Hat looks at Brian Stevens, who's the CTO of Red Hat, got up there and he said, we've been dealing with RPMs for 17 years now. RPM was a great technology, it's 17 years old, that's how we ship our software. Okay, we haven't changed. RPM really is pretty much the same as it was 17 years ago. Right? We really haven't changed that. So Docker is really about shipping software. So it's really, and the container technology is sort of like a side note. It's just, matter of fact, if you ran a single Docker container on your box, as say this is an Apache box, it's an Apache VM. This would be a different way of running one service inside the box. So you really would, in that case, why would you even care about a container, right? It being a container. All you care about is that Apache would run correctly, even if I update the host operating system from underneath it. So that's really the script. Yes.
I didn't see something along the lines of key management, like SME.
Yeah, I mean.
Is there a reason why? It looks like everything is in Core OS has done that and more, but nothing around with SD.
Yeah, Colin, you want to cover that one?
Yeah, so it's interesting. Yeah, right now, RHEL Atomic, like the Project Atomic effort is kind of taking that atomic updates pattern for the host operating system. And it is interesting to see what a lot of these organizations like CoreOS have done around the orchestration layer. And I think that's still evolving. I mean, the GearD component was coming at this from one direction, but it certainly isn't equivalent to etcd. So, yeah, I don't know exactly where this will all land, because Kubernetes obviously came in and sort of changed a lot of this stuff. But right now you can choose to run etcd, of course.
Oh, sure.
We're just not we're not baking it in to the degree that some other groups do.
I just found it interesting. Basically, everything that you need that is in all the other offerings, other than that, is there.
Yeah, I mean, so yeah, some groups definitely have like a very vertical vision of how things work, but not every organization is ready to work that way, right? So, the way I see it, particularly for like a platform project, we need to have systems that can run in a variety of ways. Maybe multiple disconnected groups, and I mean, there's a wide variety of.
So if you don't mind follow on, I used Core OS for a while, and I kind of got really irked at it because it was constantly changing of the covers on demand, and
The reboots?
the reboots, and it was driving me crazy. And you're thinking my SSH would be terminated, and
Yeah.
so I mean, like the comment I made to Dan was, so once like enterprise grade Core OS or above. You guys are dealing with that, I hope, or?
Well, okay, so yeah, I'm the upstream author of the OS3 component, which is the atomic update system. So I'd certainly be really interested in your feedback from that perspective because it doesn't do automatic reboots.
That's beautiful.
Yeah. Yeah, you run in
Change
atomic.
what I want you to change. Not what you want.
Yeah.
Surprise!
Yeah. But I think though they actually do have a very valid approach there. You know, I'm sure many of you have heard of Netflix's Chaos Monkey, right? And I think that's actually a really cool way to do systems where you are constantly ready for downtime. And I think, but yeah, see, when I've talked to a lot of real world sysadmins, they're not ready for this.
Well, a lot of
at all. And
it's a lot of enterprise. I mean, a lot of people talk about like the Netflix and how they do that, and they're like, "Oh, everything should be, designed for failure." I'm like, not everything's built that way. When you control the whole stack, you can do things like that, where you have shared state is divided up and so on, so you can plan for it. Whereas like, I get Oracle the way I get Oracle, and Oracle tells me how to run it, and I run it that way. And if I can't tell it, half the stuff will blow up, and it should still be
It's
fine.
a difference on risk, right? I mean,
Yeah.
Okay, my video industry. all
Yeah,
right.
or if I could have run, if I have 1,000 of every server, yeah, I could run 2 of everything and one could go offline, but I can't afford that.
Right.
Yeah.
The interesting thing, one of the points when the Docker guy was up there talking, Docker has this vision that everybody runs single service inside of a container. Okay, and some people think of it as being, people often say single process, and my ears go off and say, no, we're really looking at single service. And one of the reasons for that is sort of the Twitter model, right? That if you have hundreds of these little services running around the environment, you can start to deduplicate them or have them distributed, so you can have Apache servers and have front ends and databases with multiple services running on different hosts, and you can start to get these better failover scenarios. That being said, a lot of people are going to run multiple services inside of containers, right? They're going to run sort of lightweight virtualization. And right now, the only way to do that is through Supervisor D. I guess there's some other hacks. Now, Supervisor D brings in the headache of it. It's written in Python and it requires Python. So what we've done inside of Red Hat, again, with System D is we said, well, System D is the way we advise you to run your services at, it's the init system for the system, so why not make it also capable of being an init system for the container? So one of the things we're looking at coming out with one of the other things, when we released, everybody here is familiar with RHEL's release cycle, which is basically, one of the things I always like to say, the reason Red Hat makes money is we make the engineers do the stuff that nobody wants to do. So Linux, the companies that don't make money on Linux will do the cool stuff that no one's willing to pay for. So what Red Hat does is we take 8-year-old code and fix security vulnerabilities in it. And we don't just say, throw away the 8-year-old code and bring in the brand new stuff and blow your system out of the way. So, I don't know where I'm going with that. I'm going to block it. But the idea is how do we make these applications work well? So one of the things we're looking at is, so traditional, okay, that's where I was going. Traditional applications, we put them on your system and they're good for, if you were running a RHEL 6 system and you were running RHEL 6 version of Apache from 6 years ago, RHEL 5 versions from 6 years ago, it's still supported. So the traditional release cycle for RHEL is we support something for 10 years. As a matter of fact, it originally started as 4 years. So RHEL ES2.1 was 4 years, then RHEL 3 came out, and you guys made us go to 5 years, then we went to 6 years, now we're at 10 years. So slowly but surely, we keep on lengthening the time that this ancient code is continue to be supported. Well, the problem with Docker is Docker's changing too quickly for that. So we're actually have a different stream inside of RHEL now. So you order your RHEL 7 box, and you get Docker as part of extras. Now, Docker is full supported like any other application. It's just we're going to be changing it quickly, okay? Because Docker is changing way too quickly for us. So there's going to be a constant update. Constant meaning once every 2 or 3 months. You probably get the latest version of Docker once you get RHEL 7 box. So we're looking at that. Similarly, Project Atomic is probably going to move a little bit faster. So it's, a lot of this brand new technology we want to start moving as we move to this container type environment. So what we're looking at with System D is potentially putting System D will become available for containers in our next release of Docker, which will probably be in about 2 months. So now you can start to run systemd. And the beauty of this is if you have an application service that is set up to run on your system by using systemd init system, you can install it into a container and just toggle it like it's a regular systemd, and all of a sudden it'll run. So you won't have to, one of the things he was showing is all these fancy bash scripts for starting up your services. All of a sudden the systemd enabled Apache services yum install Apache, enable Apache. That's it. All you have to do is start up the service. Now if you want to run MySQL, you can say enable MySQL, and now you'll be running Apache and MySQL, so you can start to really simply build up these more complicated services. Again, that's not what Docker recommends and not necessarily what I recommend, but in certain work cases, your workloads, you're going to want to do that. And I always ended by saying Oracle's going to ship the largest container in the history of the universe. Okay? So they're going to have one container that's going to have 4,000 services running it, each one of them writing log files all over the container doing horrible things. So that's the way Oracle rolls. So.
But it's unbreakable.
IBM WebSphere
Would you provide your Docker logs in the set format for the security settings? The common event format?
The Docker logs is sort of, everybody talks about where do the log files go from this. What we would, if you're running in a systemd type of container, we're looking at getting the systemd and journald to offload. Again, systemd and journald is sort of the init system, the new journaling system that's available in RHEL 7 that gets you name, value, pairs for all tons and tons of content in addition to just standard syslog type log content. So we're looking at offshoring the syslog type information and any type of standard out, standard input into the journaling system on the host if you're running a system.